Hello, class.
Morning.
How y'all doing?
Doing great.
All right. I was over here. I found a link online to try to download a virtual box, but the box is so small on my computer that I downloaded it all. I had to try to change my settings. I'm gonna see what's gonna happen. Uh, but I do have information on this side. Okay, U.S. English, U.S. English. Cool. I'm trying to let. How many people logged in? Five. Okay. Let everybody try to log in. Special delivery. So no photo. Okay. I'll get this work. I'll work on that after class. All right. I know we got more than five people in the class. Did y'all do the registration for the room, signing on the room?
No, sir, not yet.
Yeah, y'all could go ahead on and do that. And the section is section one. So go ahead to the 2153 link and go ahead on and sign the roll.
I'm trying to sign a role, Professor, and it says you must sign on the correct day of the week.
Okay. So I may have to check the day in which I have you all set up to sign the roll. I'm not gonna have it. Well, this is Wednesday, so I'm gonna have to check to see what's the date. Let me check my let me check this out. Okay, let's see. Oh, I don't want to go there. Yes, I have Wesley Anderson, LeBray, and McArdle, who already signed. Let me see something. Let me see what I have in here. Class time, fall 2020, Wednesday. So yeah, I'm gonna have to check my code. I have the right date, but I'm gonna have to check my code. I'll check that later on. So I can add y'all for today, and then I'll add the rest. Everybody else, well, it should be ready for the next class period. So let me close this. Okay. Yeah. All right. Got one. Do we have one other person? Yeah, we got 9 people so far now. Okay. So they coming on in. Okay, if you just came in, what you could do, you could try to go into and I'll have to show you somewhat. Let me share my screen. Share my screen. Share. All right, what you have to do is go to syl9.com and hit it, and you'll be at this screen. Many of you that haven't taken my class yet, And then at this screen, you would click on the 2153 link, CSCI 2153 link. And at this link, it gives you information about the course, degree that we offer. And this is some information that we'll be using for the class. And this is where you would sign the role. You click here and you would actually first do a register. Click register, put in your name, your first name, last name, your major, and then you would select, this is section 1. It would be fall, and it would be 2020. And then this asks for the last 4 digits of your L number, which could be whatever, whatever those last 4 digits of your L number. Then you would create your password. I think the minimum requirements is at least 6 characters. Okay, you retype it in, and then you type in an email, and then you would actually click register. Once you click register, it should send you an email address. An email giving you your login name and your password. Also, once you click register, it should show you your login ID, but not your password on the screen. All right. So once that's done, you go back to the main menu, and then this time you would click student utilities, which is not working right now, but still you can still do it. Then click on sign today's role, type in your login. I think I have one. Let's see. You click continue, and it will give you the calendar. This is the actual date, and you would just simply click here, sign, click to sign a role. And as I don't know who said it, it said that it gave this error. You must sign on the correct day of the week. So, and I'll fix that, and I'll add everybody for this week. But look, just go ahead on and register, and I'll be able to add you. So go ahead on.
Yeah, it gave me that. I was wondering because I'm also in your 1943 class at the same time.
Not at the same time. Oh, you're talking about just in the same semester.
In the same semester, yeah. But I'm on your Tuesday 1943.
Right, but
class.
that was working, right?
Yeah, that one's right. Working.
Okay, no problem. But no, it's 2 different systems. When I say system, tables and whatnot. So you're in the 193 table, 194 table in the other one. Then you're in the 2103 table in this one. Yeah, so it's 2 different ones, 2 different logins. All right. So that's how you would log in. So let me see who all done actually did something so far. Let me go ahead. Okay, so I do have 1, 2, 3, 4, 5, 6, 7, 8. I'm the 9th one, but that's not it. All right, so that would be the people that's here. So all these people are here. So what I'll do, like I say, I'll go back and add you all for today and have it set up to where you can sign for the next class period. All right. Okay, so let's get started. Go back to the main menu. I'll go back to the website. Come on here. All right. So I should have went home. So here is the page on my website, which gives the course name and number, course description, an introduction to Linux operating systems. Student will learn basic Linux administration, Linux file and directory structures, basic network configurations, and how to utilize Office-related tools available in Linux. All right, so this is my name, David L. Sylvester, computer science, engineering, then it's math department. So they combined math into the computer science and engineering department recently. Not in my office now. This is our office number. The office hours, I'll show you my office hours in a little while. My email address here. This is not the, well, that's Blackboard, but this, you can scratch that because we don't use Blackboard anymore. I don't know why I put Blackboard. And this is a new thing. All right. But SimNet is for another class. And this is the SYL 9 for this class, which you already had. Calco, which is here, but it's also here, which is a terminal, and we'll go over that a little later. But what we want to do is kind of go over the syllabus. But this is our degrees that we offer, all right? And you can always look at those checklists whenever you choose to see and download them if you want so that you can see what courses you may need. But we always ask that you be advised. So, and this is pretty much a breakdown of what the course gonna be. Our first part is just introduction of operating systems, what operating systems is, file structure, etc. Then we're gonna get into different commands. Just get into, like, say, more or less commands like in Windows. Windows, we don't really know commands like we should, because when we want to copy something, we click copy. But people who manage Linux systems or Unix systems, most oftentimes they type in commands from a prompt or whatnot because they just feel more confident in that. But Windows systems use GUIs that we know of. All right, and then like I say, we have these other chapters or sections we're gonna go over. Now, let's look at our syllabus, and the syllabus is normally general. All right, this is Linux and Unix system programming. The course number is CSCI 2153. It's a 3-hour credit course. And we went over what the course description was a little while ago. Prerequisites is 193, all right, or 1933. And here's your learning outcome: understand basic commands, develop software for Unix systems. Now, not necessarily we're gonna be developing software. We can write code, some code, because you can do C. You can do your C++ in Linux. Then it's Bash files you can write in Linux. Bash files is somewhat like, if you know a little bit about Windows, it's like those startup files. Those I forgot what they call it, bat files in Windows. All right. Use important Linux and Unix library functions and system calls. So we're gonna learn commands and stuff that maintain Linux processes and whatnot. Describe the inner workings of a Linux operating system. Understanding fundamental operating system. So that's basically what we're gonna be doing. All right. We're going to be taking tests, quizzes, have assignments or projects, and presentations. We might do them online. Well, like we'll be online. We'll see. We'll see how that'll work. But we may do some presentations in the class. All right. This is my information again: my name, my office, my email, my office number. All right. They're just saying, although many issues may be solved by communicating through email, there may be times when a Zoom session is needed. Listed below are the links and password. Really you won't need the password. For Zoom sessions, it may be a good idea to confirm a Zoom meeting first. But you don't have to. But if you look here, this is my office hours, 9 to 1 on Mondays. All right. Now, on Mondays, this is the link. You click on this link, I'll have my Zoom open. And I think Mr. Gerard came in this morning. He thought that was the class link. He clicked on it, I answered, and me and him conversated as if he was in my office. All right, so that's for Monday. If it's Tuesday, now Tuesday I have a class from 11:15 to 12. 10 to 11:15. Now I would tell you, and Mr. Gerard could tell you, Mr. Marler, it may not be a good idea to try to contact me between 11:15 and 12, because normally I'm still in my class. answering questions and trying to go over stuff with them and whatnot. So, but if there's a time when we're not, then I'll be available here. And then after this class, I have a class after my what's it 10, 12. Oh yeah, then from 12 to 1:15, I have a class, but then from 1:15 to 1:30, I'll have a little small window. But normally after that class, I'm answering questions too. So it's like I'm still, in a sense, in my office, but it's like I'm with students from the class that I'm with. But on Wednesdays, like today, from 9 o'clock till class time, like or maybe maybe 5 minutes before class time, because I have to log off that Zoom to get onto the Zoom for the class. So I'll be on from 9 to 12, all right, or 9 to 11:55, and then I'll get into class, and then after class I'll be on an hour after the class, all right. So that's my office hours, and I might extend this a little bit longer on the Wednesday. It just depends. But this is how you would contact me for the office hours. Through Monday, this link. Tuesday, this link. Wednesday, this link. If you need to copy those links or send them to your phone, just send them to your phone. But like I said, this would be the Zoom links that you would contact. Now, you can still contact me through email. That's not an issue. Mr. Sylvester, hey, such and such and such, I will respond. But I'm just saying, if you wanted to conversate with me, this would be the way to go about doing it. All right. So this is the CRN 11555, CSCI 1953, and it's section 1. Our class meeting time is 12 to 1:15 on Wednesdays. It is online, but it's like we have a dedicated time. All right. So, and this is just telling you you need to register here to sign the roll. Now this say Tuesday, this should be Wednesday, and I need to change that because I need to change the time or the date in my software. So there's no book. This information, like I say, USB, that's just so you can keep your information, but we're on computers now, so you should have your computer to save your information. You must have a personal computer. Well, we know that in order to come to class, and Windows or whatever, and a webcam so that you can view the information and whatnot. All right. You can do it through your cell phone if you have to also. C compiler, the C++ compiler gonna be within should be within the window that we use, whatever shell we use. All right. Now this say responders, but recently I found out that responders is not how would I say active. So we're gonna be using Proctorian. All right. So I'll change that. So Proctorian, but that's in Canvas. I have it in Canvas where the link and to get to Proctorian to set up your computer to take tests. All right. And then you should always have access to your Canvas and your email so that you can connect to whatever. Disregard this responders link here. It's no more. All right. So now here we go. So this is some links, and we talked about some of these links. Disability services. If you do have a disability, make sure you turn in your paperwork, get the proper notifications out to the teachers, the different centers, if you're taking tests in a certain center, so that you can be accommodated. So make sure you get that done. Student conduct, we know we're not in class, but we're online, but we still need to have respect for others, background noises, whatever, however. Sometimes my phone, I forget to turn my phone off, it goes off, just simply turn it off. If you got to talk on your phone, like I said, just mute your monitor. And if you're talking with us, just mute it and go off and do what you got to do. All right. Grading scale is the same, 10-point grading scale. My percentages basically the same. If you've been in my class before, exams, 30, quizzes 10, final exam 20, discussions and reports and assignments are 35. Participation, which is normally given, is 5, and bonus is 5%, which is a total of 105%. So you got a little advantage already. Attendance policy, it say that you should log in on time and come in on time and whatever. You know, my class is flexible. I want you to come whenever you can make it because I want you to get whatever information you can out of the class. All right. So if you 10 minutes late, 5 minutes late, 30 minutes late, whatever, still, you know, Zoom on in, come on into the session. All right. No makeup quizzes. Now, you know my policy. I put this in here, you know, just in case. Now, there's no makeup policy, but you know that I kind of work with students. I'm Mr. Sylvester, look, had such and such an issue. Hey, I'll try to work with you. Now, it won't be no semester long thing, but I'll work with you as long as I see it, you know, it permits. Because if every test you have an issue, then I might have a problem. Every assignment you got a problem with submitting, then I have an issue. I'll give you an example. I had and like I say, I don't try to and when this go back to plagiarism, I don't try to catch you cheating. I don't try to intentionally give you a 0. But I had an assignment due last night. I had my 2 classes. I don't know which one it was though, but it was 193 and 194. But one of the students in one of those classes, oh, Mr. Sylvester, I can't upload my assignments. Every time I try to upload it, oh, it give me problems, this, that, and other, whatever. So I say, oh, do you have the right extensions, whatever. Oh, when I'm on my phone, my old files that I've sent previously, they work, whatever. Now, this was at 11:30. The file was due by 11:59. So I sent an email. I said, email me one of your files as an attachment, and I'll view it to see what's the problem. Never got an email. So either apparently they didn't even have a file, you know what I'm saying, trying to get extra time, you know, or they said, well, you know, I don't want to even take this chance because I know I didn't do what I was supposed to do. You know, so like I said, I don't try it, but I try to help you. You know, and I'm trying to give you zeros, but I don't want you to try to use me either, you know. So just make sure you're following the guidelines and doing whatever. Withdrawal dates, well, general policies, like I say, ask questions at any time. You know, that's what my class is. You could break in at any time, ask a question, because I'll keep on talking and talking. But then most times I'll say, oh, any question? And your question might have been 5 sentences ago. So I don't mind you stopping and interjecting and asking, oh, well, Mr. Vessel, you just said whatever. I don't have an issue with that. All right. Taking the test, it's a responders, but it will be proctorial. All right. It will be proctorial. All right. And all this says is mute the background noises. If you know you got pets, TV, whatever, just mute your mic, you know, when you're listening to the class. But if you don't have that noise or whatever distraction, you can leave your mic open. All right, if you want to. These are the withdrawal dates for the different sessions, the 15-week sessions, the 12-week sessions, the first 7-week sessions, and the second 7-week sessions. So be mindful of those withdrawal dates. And like I say, cheating and plagiarism, we kind of talked about that. And everybody know in my class, like I say, I just don't want you to recopy other people's work and turn it in. I don't have a problem with you working together. I don't have a problem with you, working in groups, but do your own work. Safety, we really don't have any safety concerns being that we're not on campus, but at the same time, it might be a chance that you may have to go on campus. Listed in here are the procedures because of the COVID situation. These are the procedures. And we know we still have the campus and we have the campus phones and whatnot still out there. So these are the procedures that you would need to follow. You have to, and then if someone have COVID, you have to report it to me. I have to file it through the Bear Cares, and then there's some protocols you have to follow. after that, to let the school know that, hey, I've been through whatever I did, whatever, sending the paperwork or whatever. So just make sure you're mindful of that. Library resources, even though we're not at the library, you might still be able to get access certain resources through these links. All right, Academic Learning Center. Now, some of you all, like say, who've taken some of my classes, like 192, you may want to contact Academic Learning Center and maybe be a tutor. Or if you're taking 193, you may want to be a tutor, for those courses. Or if you major something else and you, in your advanced classes, you may want to reach out to them to see if you can be a tutor for them. And they'll pay you, you know what I'm saying? So like I say, just up to you, if you would like to, and if they have that opportunity, for you to be a tutor. All right? Or they might have tutoring sessions for you there, because somebody else is already tutoring. Bearcats. This is Bearcats. And remember, Bearcats was there for all of us. If anybody had an issue, it could be somebody who were a staff person, faculty person, student, or even a client of BRCC. If something went on that they wasn't satisfied with or they was uncomfortable with, you can go through this link to file a grievance or file some type of complaint or whatever. So that's for anybody, teacher, student, staff, anybody. Because if you walk into a staff person office and be rude, then that staff person can file something through the Bearcats. If you walk into a teacher's classroom or office and you feel a teacher disrespected you or harass you or whatever, you could file a grievance or whatever. Or if it's something dealing with being unfairly treated with the grade or whatever, you could file a grievance. So it's for all people, for all things, that you could go through this to file grievances. All right. So this statement is very important for a student as a student, that you properly apply for the correct program of study. All right. You can check check to see if your program of study is accurately recorded by logging into your Lola account. So you can check in the Lola, see if you have your right program of study, so that when you're to be advised, we're going to advise you correctly. Also, when we pull our reports, because many times what we do, we ask the school for reports of all computer science majors. All right. And then when we get that report, and if you say, well, my major is such and such, but I'm gonna change it to computer science. I just haven't done the paperwork. You might not be in that pool, in that listing. So just make sure you have your proper program of study chosen, so that when we do reports, we can either reach out to you. You'll be in the list where we can reach out to you. And when we do statistics on classrooms or whatever, we can do the statistics. Because if you're not in your program of study, even when we do our assessments, you're not a part of the assessment if you're not recorded as being in that program. All right. And again, these are the units outline of what we're going to be going over. All right. So that's the syllabus. Anybody have any questions so far? No questions. All right. So let me get back to, So here is our, in the SYL site. So if you look here, I have this Calco Linux terminal. If you click on it, it should bring you up into a terminal, and then you could say run the terminal now or sign in. You can go ahead and create something to sign in, or you can just simply click run terminal, and you'll be at open in a, well, you're not really yet. Let's see, welcome. I think this one ain't gonna come up right. No, this is not the one gonna come up right. It should come up though. It's taking its time, but it should take you in And you can add files like, see, this is a C++ file. Oh, come on. Wow. So let me see if I can add a terminal here. I might have to create one. Let's see. I'll just say new, and I'll say terminal. I'll create a terminal, and I'll just give it a class. Okay, I'll say create a terminal. And all of a sudden, see, I'm in a terminal. So now in this terminal, I could do some things, whatever, that we're going to go over later. You know, I could say ls, which ls is like a listing, like doing a directory of your folder. All right. So now it's saying that I have a class1.term file. All right. I have a a.out file, and I have a test.c file in this particular, in my folder. Now, one thing we're gonna learn is VI. If I want to look at the contents of test, and like I say, I'm just showing you this, but we're gonna go I'll go test.c, VI test.c. This is what's in the file test.c. Now, I use VI. There's many other editors, but I want you to kind of look at VI and see how it was manipulated, how hard it was to use, as opposed to the editors that we use of today. But we're not going to do that today. I'm just telling you. So I need to save this. I didn't make changes, so I can hold the shift key down and I'll do ZZ, and it takes me out of the file. But you'll see all that. Because I think I have a link for you to get to the VI command. So if I wanted to run that C++ file in this shell, in this terminal, I have to do G++ and then test.c, right? I have to do G++, and then I hit enter, and now I got the $sign. The $sign return means that it executed, it's compiled correctly, and now I can execute it. In Linux systems, what you get is a.out file. Now, I cannot just say a.out, because what happens is, by default, it's looking somewhere else for the a.out file. But I do have the a.out. See, I have an a.out here, but it's overwritten. If I do a ls-l again, watch the date. Look at the time. This one is September 9th at 2 o'clock. This one is September 9th at 5 o'clock. What is 5 o'clock? Well, it might be on their time, whatever their time is. Because 1752 is 5 o'clock. So I don't know what server we on, what country we in or whatever. But if I wanted to execute that a.out file, I have to do /a.out. Okay. And then I hit enter, and look, that's my output. This is the test. So you understand? So now if you want it, you probably could do some of your C++ files on here, but your error message might be a little different. You know what I'm saying? And when I say a little different, they might be worded different because this is a different compiler. But you would get the error, but the explanation might just be a little different, so because the different compilers, they create their own error messages, all right? But they're all similar. And if you try to compare the error messages, they should be very, very similar, all right? So, but that's one of them. And I'll just, if I can add to, I can't exit. So what I'll do, all I'll do is just close out, and I'm out of it. So I'm back here. But let me get where I was. I exited out. I sure did. I exited out my thing. So here, go back here. And then I have another one. This one runs a Linux box. All right. This is a Linux box that I have here. So it'll take a little time. But now this one allows me to it's limited me to certain things also. If I do ls-l, you see, now it gives me some files. Now, in this one, I cannot run C++ files because it's going to tell me if I do the G++, and I do hello, see G++ not found. But if I do something like GCC and then I do hello.c, oh man, GCC hello.c, if I hit enter. Wow. Now, well, let's do this first. VI, it compiled, but watch the coding. Look at this. What is the header files? How many people that took my C classes? You see these header files? This is C. This is not C++. You got me? So if I tried to run a C++ file on this compiler, I would get errors. So I would have to change my libraries. I'd have to know which libraries are compatible to the C++ libraries. Okay? Now, look at this output statement. Now, this is a C out statement in C++, but in C, what? Printf. It's similar here, what? Double quotes, whatever I want in double quotes, \n, right? Close the double quotes. So that's saying what? Hello world, new line, right? So it's similar, but different. So you see when we was trying to teach you about C++ and telling you, learn C++, be able to migrate to the different softwares because they're gonna be similar, but different, right? They'll be similar, but different. Okay, so I'll get out of there, Shift ZZ, and then what I'll do a dot, /a.out, and look, hello world. You see? So basically, two programs written two different ways that does the same thing, write an output, right? One wrote this is a test, this one wrote hello world. One was in C++, this one was in C. All right. So and then this is the shell. All right. So that's another shell. And for this one, I never worked with too much, but this is another shell you can somewhat work with. All right. But this one, I'm not sure as to, well, this one working with just the bash. All right. Just the bash. So it's like hello world. So I echo hello world because it's almost like you writing the bash file, you know. So you're not actually you're writing code, but it's not like a C or C++ program. All right, because I could put another echo down here and echo something else. But notice on the right, this is what is output. Hello world. All right. So these are some different shells that we have. Oh, I don't want to do that, Kels. I want to go back. Okay, on the lead. All right. So it's one. I could give y'all the link, but it's a virtual box. At the beginning of the class, I was telling some of the students I was trying to install this virtual box within Windows on my other PC, and I didn't want to try to do it on this one, and then it crashes, and then I couldn't have class. So, and I'm gonna see how it works and whatnot. Right now, it seems like it's working so far, but my resolution is small, so that I'm gonna have to figure out how to increase the resolution. Once I do that, I might give it to you as assignment to create and then it all depends on how much resources you have on your laptop or your computer also. So, because I don't want you to install something or try to install something on your computer that's gonna make it crash. But hopefully this won't take up a whole lot and won't cause any big or major problems with your computer. All right. So those are the different things. Now, all right. So now, starting the lecture. All right. This is Linux. Anybody have any questions? Questions? All right. All right. System programming. All right. What is I need to move this thing I'm doing. All right, here we go. What is an operating system? Now, this can be dealing with any Windows, Windows, Linux, Solaris, whatever. An operating system. An operating system is software that manages the computer hardware. So when you have Windows on your system, Windows manage any and every device that you have on your computer. If Windows can't manage it, then or manage a half of the devices you have on your computer, you would then say, well, this is a bad operating system, right? It's no use to me because the components that I'm trying to add to my system doesn't work with that operating system, or either the operating system is bogged down as I add these components. So that operating system has to be able to manage that hardware, but it needs to do it efficiently also. So there's a lot of things that be going on in the background that we don't even worry about that the operating system has to do. All right. The hardware must provide appropriate mechanisms to ensure the correct operation of the computer system and to prevent user programs from interfering with the proper operation of the system. So what? That comes in where we may talk about either, well, when we really get down into it, when people start putting in viruses, where one device may hog another device, take over another device, or one application or file is taking control of the process of what's going on in the system. All right, but that operating system is supposed to efficiently control everything. All right, hey, I got so many processes going on. It needs to have those processes in some type of stack. Okay, what goes first? What goes next? Or what order that we're gonna go in bit by bit. So it needs to manage all that stuff and then do it in an efficient way to where your system runs smoothly. All right. A program, okay, that's again, an operating system is a program that controls the execution of application programs and act as an interface between the user and the computer hardware. So, like I say, when you execute some software, the computer has to say, okay, I'm managing and executing system software, but now that user is requesting some execute, so I have to blend it in, but at the same time managing the execution of my system software and not interfering with the integrity of my operating system process. I still have to process whether I'm going into opening a web browser, whether I'm downloading some files from the internet or whatever. So it needs to have all that stuff in order. And now we know that back in the day it was a single user system. Now most of our systems are multitasking. So that then added more to what that operating system has to do and how it has to manage it and make sure that it runs smoothly. So it is a lot that the operating system does that we don't worry about. All we want to do is come up, give us what we want in a timely manner, and go and move on. All right. And it says it's the one program running at all times, usually called the kernel. So that system should be always running because that's what manages everything on the computer. Okay. With all else being applications programs. So you have your kernel or your operating system, and then after that you have all your application programs that should be running on your computer. Okay? So functions of an operating system. Let me try to move this thing over. All right. So functions of operating system, all right. Convenient. An operating system, or we have abbreviated OS, makes a computer more convenient to use. All right. So that operating system, back in the day, many times they had to manually execute this, execute that, execute the other. But we know that nowadays, more operating systems now, when you plug in say you had a mouse, a wireless mouse, and when you plug it in your computer, what happens normally?
It
You hear a little,
it
go
auto
ahead.
detects it, and then it'll install whatever drivers needed, and it'll just start working. Plug and play.
Correct. So you see what I'm saying? And that's all done through that operating system, correct? So that operating system monitoring your computer, monitoring those different ports. So when you plug that device in, it says, okay, a new device come in. Let me see if I have that driver. If that driver is there, oh, okay. All right, now it's set up to be used. So like I said, now the operating systems are making it more convenient for you to use a computer without having to have all this knowledge of, oh, well, I need to do this. I need to create this file. I need to, unzip this and explode it, implode it to this and install this or whatever. It does a lot of that for you now. All right. Efficiency. An operating system allows a computer system resources to be used in an efficient manner. Now, with many larger systems, things are placed on a priority level. All right. Because sometimes you might have users that may have a higher priority to do things than other people. Give an example. If you had a company and you had your boss and maybe your executive, and then you had the regular workers, when information was sent to the printer, the boss may be given a higher priority, you understand, for print information than a regular staff person. So what happens when those jobs go to that queue, it's like, oh, well, this one has a higher priority. Whatever's being printed, it will be sent, but then all of a sudden, the one being sent, it could be in the bottom of the stack. It'll be moved up based on its priority. So, like I say, it'll make your system manage everything more efficiently. And even when it's dealing with the resources, nowadays, okay, how much memory you want to allocate to whatever, how much storage you want to give to whatever. You can manage your system in that fashion so that it makes it more it'll be able to run more efficiently. All right. Then the ability to evolve. An operating system should be constructed in such a way as to permit the effective development, testing, and introduction of new system functions at the same time without interfering with services. So all of a sudden now if a new application or new technology or new whatever is introduced, provided, sometimes it works, sometimes it doesn't. It depends on the architecture and whatever that's needed for that software to run. But generally, that operating system should be able to advance or grow, rather than just say, this is what I do, and anything outside of that, you have to find another one. It's kind of useless because you don't want to build your company on some software that, hey, this is the software we developed. This is all that our capability. This is all its capabilities, and outside of that, hey, you're stuck. You might think twice before you try to buy some software like that, because as soon as something different or new comes out, and it might be something that can be beneficial to the process of your company, you stuck because you done invested it all into that operating system. And grant you, it's very, very costly and time consuming when you have to change over from one system to another system. So you want to be very, very, very cautious when you're dealing with operating systems and which one you choose. All right. So let's look somewhat how the operating system kind of is viewed. All right. So you have your hardware. So just your hardware by itself is just what? Piece of equipment, right? It's just something that's there. It can't do anything. If you got a computer that doesn't have an operating system on, you could turn it on all you want. It won't do anything, right? Then what? You load that operating system on it. Then now you have a computer with an operating system, but now you have system software within that operating system, right? But then you also can add what? Applications on top of that. So that would be on that tier. So now you have the system software, and then you may have other applications, programs that you can add. And then they give examples, like one user, and this is multitasking environment, one user might come in and use the application, which is the compiler. Another user might come in and use what? A text editor. One might come in and use an assembly language. Another might come in and use a database system. So, but that operating system still should what? Be able to efficiently and effectively control the software and the equipment that's being attached to it so that it can what? Run smoothly and everybody can get the proper time sharing and all that. So, like I say, that operating system has to be developed so that it can run efficiently. Otherwise, it's useless. All right. So, and then, like I say, in general, a general purpose computer consists of, and that's just normally a basic computer, hardware, all right, which we know is our memory, CPU. On the CPU is got the arithmetic logic unit, all right. Now, our OS device, I/O devices, input/output devices, other peripheral devices, mouse, keyboard, and all that other stuff, and our storage devices could be external drives, USBs, et cetera, et cetera, et cetera, right? All those different devices, that's hardware, right? Then we have system programs, all right? Now, system programs are on top of application programs. System programs are needed to run the actual, work with the operating system, all right? So it could consist of compilers, loaders, editors, etc. But then application programs would be programs that you, how would I say, you use or for your purposes, like say a text, a database program or a window, or a Word document or some Word program or whatever. So those are the application programs, all right? And then we have a user or users, and that would be the person at the what we call them end users. They're the ones just using whatever's available on the system, all right? They may have to log in and then what? Have access, have certain privileges to access certain software, okay? All right, input-output system management, all right? So the module that keeps track of the status of devices is called the I/O traffic controller, okay? Each I/O device has a device handler that resides in a separate process associated with that device. Because what? With a computer, everything deals with what? Input and output, right? When we sending something to the screen, input and output. When we're sending something through the internet, through the cables, we input things, which traffic it in, and we output things. So the computer itself have a lot of different places where information is being inputted and outputted, all right? So I/O subsystems consist of memory management, because what? When I click to execute a file, and that file has to be loaded in memory. Once it's loaded in memory, then it has to be what? Sent through the CPU, then executed. So information has to be sent and received, sent and received, sent and received. All right. So it says that so it's a memory management component that includes buffering, caching, and spooling. All right. And I should have added that one, but I didn't add it, but I'll leave that. And I'm talking about for your assignment. All right. A general device interface. All right. So, like I say, normally they have their device interface, so where you actually have to connect it to something. All right. Drivers for specific hardware devices Because what? Every device that you have on a computer, even though some of them are built in or into the RAM, I'm not the RAM, into the ROM, because what? When we turn on our computer, most oftentimes, what? Our keyboard is pretty much built in the ROM. It'll give us a default, but you can have other keyboard. But normally when you, a printer, a mouse, external hard drive, even a external CD drive, those devices have particular drivers that is, even a printer, that's needed in order for that device to properly work within that operating system on that computer. And so we have to have those specific drivers. Because how many people have ever had the wrong driver for a device? Like say a printer. If you had the wrong driver installed for a printer, what happens when you try to print?
Errors, right?
You either get gibberish, you know, remember how you get, it'll start beeping and printing out the happy faces and whatever, right? Or it won't print at all because that driver cannot, that computer and the operating system on that computer cannot communicate with one another. All right, so you have to have that driver. So this is an assignment, and it's in Canvas already. All right, so this is one assignment that I want you to do. All right, write a one-page document elaborating on spooling and buffering. All right, and then I want you to give me the differences or the difference between spooling and buffering. All right, I want you to have a cover page that will include your name, course title, course number, date and time, instructor's name, and the due date. Okay, and a works cited page. And then the assignment should be uploaded to Canvas. So a cover page, the one-page document on dealing with spooling and buffering, and then your works cited. All right, and it's already in Canvas.
Mr. Sylvester,
Yeah.
do you still have your PowerPoints on your website?
That's what this is.
Okay.
That's what this is on the website. If you look, let me go back. I'm gonna come back.
You
If
can
I
see
go
them
back
on the
here,
address bar.
right? You see here? Yeah, you can do that too. But you see here in the page, in this page here,
Mm-hmm.
right? That's that one. Now I need to add the others to this, but I have this one and this one set up. So when you click here, it's taking you straight to what we went over. You understand?
All right.
Right. All right. So now the second assignment, all right, the device driver, all right, and the purpose and their purpose. So write a one-page document pertaining to device drivers and their purpose within the operating system. All right. Also include the cover page and blah 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 blah, and the works cited. All right. So 2 documents, 2 different links in Canvas. If you look in Canvas, if I go back to under modules, everybody who's taking my class normally know under modules, you'll see, do you? Oh, it's an assignment. An assignment, you'll see spooling and buffering, and then you see device drivers and purpose. And if you notice, I'll have in here, write a one-page document, whatever. The document, what it should consist of. And then what? Document should be double space, font name, Times New Roman, font size 12, 1-inch top, bottom, left, and right margin. So outside of that, hey, but that's all, that's what I want. Everybody, and I got there double space. Right? Everybody understand that? All right. No, so that is those 2 assignments. All right. So input output system management. All right. We have assembler, compilers, and loaders. All right. Assembler, a program that takes basic computer instructions and convert them into a pattern of what? Zeros and ones, right? That the computer processor can use to perform its basic tasks. And we know that the computer can only read what? Zeros and ones, right? So, and compilers are programs that program that processes statements, all right? So now what? We are writing statements like we're doing in what? C++. You're writing actual statements, and those statements are then converted and then even converted down to assembler language so that the computer can what? Read and understand the zeros and ones, all right? Now, then you have a loader, which is part of the operating system, and it is responsible for loading programs and libraries. And you know, we've loaded libraries from compilers, but then it has libraries that run its assembler based upon what is needed and whatnot as it performs certain operations. All right. Now, the evolution of the operating system, all right, of operating systems. And it just give you the first generation, you know. Remember the back in the day, we had like the computers was like switchboards where you had to unplug something and plug it into another, unplug it, plug it into another address, right? And they were done using vacuum tubes. And then they moved on to batch systems where they had transistors. Now, a batch system is a system where it's almost like you took processes and you just kept them, like you took a lot of processes, you just kept them, took them, kept receiving them, and then you may have processed them all late at night so that in the morning, then all your processes, if they work right, they'd be ran. If not, they had to go back and try to do them. Then they had the multi-programming, and multi-programming was what? It can actually program execute multiple things at one time. It didn't have to worry about, well, give me a whole lot of them, then I'll run them, then I'll give them back to you. Give me another a batch of them, I'll run them, then I'll give them back to you. But that multitasking, it'll take it, execute it, take it, execute, and do them in you know, all at the same time. So that what? If you had process 1, 2, and 3, they were all progressing at the same time. All right. It's kind of like you have a project and you got 3 groups, and each group is working independently to do a total project. So by the time you come to the end, everybody just put everything together and it works. That's like a multi-program. More than one can work at one time. Then you had the PC, which was where you had large-scale integration, where you had more multi-program, which you was able to do a whole lot more. And now, even though the cell phones and the tablets could be smaller than a computer, it can process a whole lot more. And those are the 5th generation. Parallel processing. So all of a sudden now, most times people do parallel programming, parallel processing. You process in one program where you don't split it up. You're processing it and then you're giving output. You know, but parallel programming it can be hard. You know, because the whole thing is that both is dependent on each other, but it's parallel, so it's split up to where one is getting executing for a result, the other one executing for a result, but they're all coming out for getting the same result. And they say it almost like artificial intelligence. All right, that's a part of the 5th generation operating systems also. All right, so computers have come a long, long way. So you batch sequence jobs of a program on a computer without manual intervention. But like I say, you had multiple whatever, then you have to perform them, then go back. Time sharing allows many users to share the computer resources. Then distributed operating systems where it managed a group of different computers and it make it appear to be a single program, all right? And I got that one twice. Then you got network operating systems. So we pretty much know networking, where computers are running in a different operating system can participate in common networks. So like what we have, Linux systems, we have Mac OS systems, we have the cell phones, we have Windows, and what they all can integrate and go to a web server or wherever and access the same information, on a common network. All right, and then you have real-time operating systems. Okay, meant application to a fixed deadline. All right, so that's real time. I'm trying to do this right now and get it done. So it's like real time. All right. All right. So now, did I? Yeah. Did I? I think I. Hold up. Hold up. Let's see something. Yeah. Okay. I needed to reload because I have some more files. I knew I had some more, but my cache wasn't loaded. Wasn't loaded. All right. So now, let's look at this. The process table. All right. Managing processes is one of the kernels or the operating system's biggest responsibility. All right. It decides which process actually gets to run on the CPU. All right. So when you, like I say, in designing the operating system, like I say, it's tough to design an operating system. But like I say, in just dealing with the processes with the operating system, it has to know what process get executed, when, how long, how much time, etc. And in my other class, in that operating system class, we talked about clock time. All right. So sometimes you have systems that have FIFO, first in, first out. Some operating systems are like that. If I put in my job first to be executed, no matter who come after me, they gotta wait. Now that could be an advantage if for small jobs. People just submit small jobs. But what if I submit a job that take 12 hours, and then I got a whole lot of people. I got 20 people behind me that got jobs that might take maybe 2 minutes to run. But I submit mine, and the system is operating on first in, first out. These people gonna have to wait those 12 hours until my job finished just to get their 1 minute process. You understand? So first in, first out is good for small jobs. Now, there's another one. What is called the shortest job first. You can do the shortest job first. So if you have a stack and then you do the shortest job first, it'll work in a sense for short jobs. But all your larger jobs might always stay where? At the bottom of the stack. Because if I have 5 jobs above, I got that 12-hour job that I want to run. And I got 5 2-minute jobs above me. But then right before my job is executed, another 20 jobs come that's maybe 10 minutes and 20 minutes or whatever. I still gotta wait. So my job might stay waiting until there's nobody in the office. Then all of a sudden my job might hit the queue. So that could be a disadvantage. Shortest job first. So you have different mechanisms for processes, and normally the process is where everybody get an equal amount of clock time. All right. Whereas if I got 15 jobs, everybody get 1 clock tick, and it keeps going until everybody's job is complete. So that way it shows where everybody is progressing at the same time. But really it's looking like, all my job went before yours. No, if you got your little smidget of a time, went to the next one, and it does it so fast you really don't know it. And it does everybody's job just going around about, giving everybody a small clock, a small amount of time executing until every job comes out. All right. So the kernel keeps the data structure, all right, in the kernel space to track information about the process, about processes. The process table, all right? So you have a process table. And like I say, depending on if you have priorities set, all right, the stack, what's in the stack, when it's supposed to come out, or what's on top of the stack, all that. Each process has an entry in this table. Entries are called process control blocks, all right? So that includes all sorts of information, all right? The process ID is one piece of information, all right? Okay, we'll look at some of those shortly, and let's look at it. All right, you can actually look at all of this process table information by examining the files, okay? So if we look at this, and I'll go back to the calco, let me pull up the calco, and let's see something. I'll do this, I'll do this, and I'll do this, and click on the calco, and go to the terminal. Go to sample. All right. I thought okay, there you go. Come on. All right. So I have this terminal here, right? I'll do clear. Clear just clears the screen. So it just wiped the screen clear. So if I do a PS, now this shows the processes. All right. So I have a process ID of what? 426. And then I have the process ID of the what? I executed PS. So this process ID was 461. All right. So it shows you that. All right. So, and then there's these other commands, ls proc. So it shows us all these files really that are there. These are some processes here. So now, if you notice here, it says I can show all the processes of a system with a process ID. Let's see where it's at. With the process ID of 1. All right. So if I go down here and I do ls minus pr -1 or type, so see, it shows all these processes of -1, and all of these should be basically dealing with the system itself. The one I did was the PS, and that one was had a process ID. Now see, I changed because what? I ran it again. It assigned me what? A new process ID because it's another process. All right. So those are processes, and those processes has to be managed by the operating system. Also, there are commands where you can kill processes. We'll go over that and everything. Now, in Windows, what we do to kill a process?
You can a bunch of different things.
Yeah,
Press
like
X, Alt F4. You can go to Task Manager and
Task Manager. Right. Normally, when you go to the Task Manager, I'll just try to see if I. Oh no! See, I can't even get to the Task Manager. Oh no! I might have to go down here. No, I don't see it here.
There it is. It's third from the bottom.
Okay. When I go to the Task Manager, notice these are all running, correct? And I can click on it and look, in task. That's just the same as kill. You know what I'm saying? Same as kill. But it's just different. With Linux and Unix, more Linux users, like I said, dealt with command prompt. They didn't deal with the Windows, side of it, like the graphical interfaces. They dealt with command prompts where, like I say, you would go to, where was I? Did I cancel out? No, I don't think I did. No. They don't. They dealt with the $ prompt. All right. A lot of things they did was from here. When they mounted a drive, they did it from here. when they executed a app or something, they did it from there. You know, just recently, and I wouldn't say recently, a few years ago, they started delving into to graphical interfaces for like Linux and Windows. But before, man, they were strictly, you know, command prompts, dealt with command prompts. All right. So now, and we talked about that. Okay, and I was saying that to stop a process, look here, kill and -9, and then what? The number of that process. So look at another command. This PS command -F will list the user or the owner or the user ID, you know, and then the process ID, and then I forgot exactly what this one is, PPID, but it's an ID, the time, the date, or this is the time. Then here we go with the other time, this time here, and this is the file that it was talking about, or the process. So if I go back to, I have to go back here, and I did a PS -F, see, it shows me the process. See this process here? This is that process, right, of what I just typed up here. And notice it gave it another process ID. Well, this is the process ID of 5 something. So see how the process ID will keep incrementing as I type it in? It keep incrementing. All right. So these are, and like I said, I could kill, but I don't want to kill anything. I know it probably won't give me a error, but most of these batch jobs like this, or these terminals, they control you from really doing anything to the system. All right. And let's see, and that's process ID 547. It might not be found. No process. So why wasn't it a process? Why wasn't this a process?
Because it executed and then it's done.
Right. After it executed it, it was finished, right? But it was a process when it gave the list, correct? But once it gave me the $, that means it had done what? Executed and finished. Right. Right. All right. So it tells us that ending a process can be done in several ways, often from a console-based command, sending a Control-C. Now, Control-C, many times we call that a what? Begin with an I. An interrupt, right? So it's an interrupt. What you're doing is if you have something that's running and you don't want it to run, and you hit Control-C, or like, how many of you been in your C++ programs that was in an infinite loop? You hit Control-C, that's an interrupt. Anything that would break you out of that would be a system interrupt. All right, and normally Control-C is a standard for interrupt. All right, so that's one of the strokes. So, and which will exit a command. All right, this works when the process is running in the foreground mode. If the process is running in the background, you should get the job ID using the PS command, and then after that, you can use the kill command to kill the process. So if you have on a Linux system or Unix system, and you got some job running or something running, you're like, man, I don't want this. I don't want it running. You could type this command PS -F to give you that list, and then you find that process ID, and then you can run that kill command, and it'll wipe it out, just like when we did that end task when we went to Windows. All right. So the kill command terminates which is the first one process. It just called first one because what? That was the name of it here, right? So the first one process. If the process ignores a regular kill command, you can use a -9 followed by the process ID. All right. All right.
Can you explain what the -9 is? Is that just from a set of numbers that specific to? I don't understand what the -9 is.
I don't think that what it is. I don't actually know, but I'm thinking the -9 is a set. I want to say a library, but a set number or command to say, hey, if you see -9, I might with it all. It could be -9. It's like I don't want no confirmation. I don't want no whatever. Just kill it. You know what I'm
Right.
saying?
It's stronger.
Yeah,
Yeah.
it's like emergency. Yeah,
Got you.
yeah, kill it. Yeah, yeah, yeah. So, the parent and child process. Now, what happens is that's what that was. PPID. Remember, I said I didn't realize the parent process. So what that means is the PPID. That means it's a parent, meaning there's a process that then broke off of it, or that's dependent on it. Parent, and there's a parent-child relationship. All right. So what happens is says each Unix process has two ID numbers. It's assigned to, which is the process ID and the parent process ID. Each user process is in the system has a parent process. So you can have a parent, and then from that parent, it can break off to many other processes. All right. So what happens is that's why you have that parent process, and it knows that when you kill that parent, you kill everything beneath it also. All right. So most of the commands that you run have the run has the shell as the parent. Okay. Check the PS-F example. Okay, where this command lists both the process ID and the parent process ID. All right. So I don't know if I used that command. Yeah, I did the -F. Yeah. But then it gave the what? This is the parent ID, and I mean the process ID, and this the parent process ID. All right. So that's what they was telling us. Now, what happens is when you kill a parent and it has a child, all of a sudden the child become what? Orphan, right? So it's like it don't have nothing to relate with. I said it killed it, but it says normally when a child process is killed, the parent process is updated via the SIG, all right, CHLD signal, all right? So then the parent can do other tasks or even restart and create a new child if needed, all right? So what happens is, like I said, you have all these processes running, and then a process might have a sub process, which would be a child that's doing something else. However, sometimes the parent process is killed before its child is killed. In this case, the parent of all processes, the init process, becomes the new PPID. So it does not, I said it killed it, but it does not kill the child. What happened, the child takes on the init, and the init is a process, and even they have an init folder in Linux or Unix. So the init process takes on the parent responsibility. So it says becomes the new PPID, parent process ID, okay? In some cases, these processes are called orphan processes, all right? So meaning the parent was killed, and then they took on the init process as what a child of the parent. So with the process, when a process is killed, a PS listing may still show the process with a Z state, which is what? A zombie state. This is a zombie or defunct process. The process is dead and not being used. These processes are different from the orphans process. They have completed execution, but still find an entry in the process table. So it's like they're sitting out there dormant, but it's like they're really not being executed. They're unlike the child. Remember, the child takes on the init PPID, so it still is active and doing something. Whereas when something is zombie, it has already completed, but then it's like I say, just out there hanging or lingering. All right, so that's zombies, and and orphans. Okay. Now, daemons, all right, are system-related background processes. Daemons, how would I say it? Like say, notice here. Look at can y'all see that little window I just popped up at the bottom? Under
Yes,
my
sir. We see
web.
it. Yes,
Yeah,
sir.
y'all see it?
Yes, sir.
Like this would somewhat be considered demons. Like see this Intel HD graphics? That's running in my background. You know what I'm saying? That's what, in a sense, what demons are. It's like processes, system-related background processes. Then they normally what? Always running. For some reason, they managing something or doing something. But depending on how you have your system set up, certain demons you may not want. You know what I'm saying? You may not want those demons. But they're often running in the background, all right? And they often run with permissions of what? Root. So now if they're running with permissions of root, you as a user, a simple user can't what? You can't just kill them. You can't just change them. So in 9 times out of 10, you can't just access them because root or super user is the highest level of user. That's almost like when you load a Windows system and what? The highest user on the Windows system is the what?
The admin.
Administrator, right. So the same thing with Linux, the highest form of a user is a super user or the root user. All right. So when something running at the root, the only person that can access that is that super user or that root user. All right. And server requests about other processes. A daemon has no controlling terminal. All right. It cannot open /DVD, or that's the dev where all the devices /TTY. All right. If you do not, if you do a PS minus EF, it looks like look at the TTY field. All daemons will have a dollar sign, a question mark for the TTY. All right. Just to be precise, a daemon is a process that runs in the background, like we just said, usually waiting for something to happen. So what? Until something happened, but it's there. It's almost like an antivirus software. It's running in that background. Soon as you execute a file that has a what? Has a virus or has some type of violation, boom, it's gonna go into effect and do something. So it's waiting for something to happen that it is capable of working with. Right? For example, a printer daemon. So what? You have your printer driver loaded, but now you have this daemon saying what? When I print something, hey, my printer queue is waiting, and when you activate that command to print, bam, then I'll go ahead on and print whatever. So it's waiting for that print command. When you send that file to be printed, boom, it activates to print. So if you have a program that calls for lengthy processing, all right, then it's work to make the daemon, make it a daemon and run it in the background. All right. So like I say, a lengthy process. So so you don't want what? That program to be what? Running at all times. Just sit there when it's called upon, boom, then activate it, and then it'll run. Now, this top command, all this top command does is it kind of lists your processes in the order from top to bottom. All right. So the top command is a very useful tool for quickly showing processes sorted by various criteria. All right. What time it is? 1:28. I'm gonna finish this page and I'll execute that command and then we'll go. All right. It is an interactive diagnostic tool that updates frequently and shows information about physical and virtual memory, or CPU usage, load averages, and your busy processes. Again, it shows you here. So if I go back to what? Okay. And I just say top. So notice what it did. Look here. 1. Oh, so now what? This one is the one on top. See, so you see how it's showing you which process is the one that's on top? So what user? What is the username? Let's see. I can't see it. Okay. or whatever file is in you. So right now, this node is on top. TITN, that's SH, then SHD bash, and then top is a low priority down here. But notice they give you the PID, okay, and then they give you the user. Don't know what this one is or this one. One of these are byte sizes. All right. This reserve. All right. Amount of CPU, amount of memory, the time. All right. And this is the actual command that's being executed. All right. And this is looks like the clock time. How much time has been used? Let's see if it changed. When it changed again. Okay, it changed. 11. Right, it's 1182.
I think it keeps updating each time it refreshes, and that's how long it takes for.
Right, but and each time you get the clock, new clock tick as
Yes,
to
sir.
how much it processed it. Right, but it lets you know which one is on top at that time being executed. Right, but that's the top command. So if you was a system administrator and you wanted to check activities on whatever, you can you do that top. And then you can see if they got erroneous activity or some file running that you don't really recognize and stuff like that. So you can kill it or do whatever, monitor it or whatnot. Yeah. Yeah. So like I say, Linux, man, Linux is more or less that prompt oriented from the prompt. So on next class period, like I say, do my 2 assignments. And next class period, we'll talk about these here. Now, I won't be able to do this ping here from that. Now, maybe once I load the shell from my computer, I may be able to do a ping. But in these bash shells, I can't do a ping or any one of the FTP, telnet. FTP. All you're doing is connecting to another system to try to to either download or upload a file to a particular server or computer. FTP is a process of trying to connect to a system, over the internet. All right. Many times you can telnet into another Linux server and then use its resources. All right. And then they got something called Finger. That's another feature that I can't use with the bash. It's a feature that allows you to see, the different information about users on that whole system. All right, but we'll continue on next class period. But go ahead on and do my assignments. What I'll do, I'll try to see how this load come, and maybe next class period we'll take the time to try to install. See if everybody can install this virtual box, so that we can use it as our Linux box to do some things. All right.
Yes, sir. Do you do you mind fixing the hyperlink on like you said, to get this version? Because when you click, when we're going to the
slide 9. You're talking about this PowerPoint?
Yes, sir.
Oh no. What it is, your cache, you're gonna have to refresh it 2 or 3 times. Like click the refresh, reload screen 2 or 3 times.
Yes, sir. Let me see if I can find it, because of what
you in Windows?
Yes, sir. Well, one of the students.
Look at the top.
Yes, sir. I was able to get the link, but when I'm on the slide 9 website and I click on lesson 1. Oh, okay. Yeah, it's the introduction to Unix. That's what we're on. Excuse me. I was tripping.
What you was on?
I was clicking on lesson 1.
Yeah. Okay, yeah. Right. And then too, like I say, remember I had to refresh my screen because it didn't show those added slides that I had.
Yes, sir. I'm tracking.
I uploaded it, and then my cache wasn't changed. Yeah.
Cool. All right.
All right. Yeah, that's it. I'll see y'all on next Wednesday, and I'm gonna fix that login too.
Yes, sir. Have a good day.
All right, y'all too.
Bye.
All right, bye-bye. What up, Miss Show?
How you doing?
All right, all right. Y'all got y'all shirts?
No, I don't think so.
You need to call them at the bookstore and see if they received them. Because remember
Okay,
me, remember me.
they probably didn't because of the virus. They got an excuse now.
No, they don't. That's too long now. And like I said, because remember me and Mr. Cox went and told them to go ahead on and order. So
Right.
she went on and ordered them, so she should have them. Yeah. So if you got her email or whatever, go ahead
Yeah,
on.
I never heard anything else about it.
Yeah, but just call her and remind her, because she might have that box stored somewhere. Yeah.
Ain't no telling.
All
I
right,
will.
then. All right. How my little partner
See
doing?
you next week.
All right.
Oh my goodness. He's doing online learning.
Oh yeah, but I tell you. I bet that's boring to him, huh?
Oh, I don't even know. Oh my, he hates it.
Right. I was saying, because it's like sitting there, I know this already.
If I don't physically,
huh?
yeah, if I don't physically sit next to him, he will not focus.
Right, he ain't gonna pay attention. Yeah. Yeah, I tell you.
It's like watching an 8-hour-long movie you don't want to see.
I know. Oh boy, yep, man. Yep. All right then. Yeah.
All right, see.
All right. Bye bye.